Alright, notes 12.3. A closer look at if-then statements. In logic, if the promise of a conditional statement is broken, then the conditional is said to be false. Otherwise, it's said to be true. So, suppose that your neighbor makes the following promise. If you mow my lawn, then I'll give you $10. Well, there's four things that can happen. You mow the lawn, your neighbor gives you $10. Well, they keep the promise, and the conditional is said to be true. You mow the lawn, your neighbor doesn't give you the $10. Well, the promise is broken, so it's false. Well, you don't mow the lawn, but you get the $10. Well, the promise isn't broken because you still got the $10, so it's said to be true. And then the last one, you do not mow the lawn, and your neighbor doesn't give you $10. Well, the promise isn't broken, so it's said to be true because you didn't mow the lawn, so you didn't get the $10. Now, our truth table for a conditional. So if we look at this one, if you work hard, then you'll get an A in class. Well, we can make a truth table for this. Alright, so the four situations. Alright, we can have P is true, true, false, false. Q is going to be true, false, true, false. If P, so if P, then Q. Well, true, true is true. True, false, that will give you a false statement. That's, the promise was broken. You did it, but the promise was broken. So therefore, it's false. Well, you didn't do it, but you still got it. That's true. You didn't do it, so you didn't get it. So that's still true. So we get true, false, true, true. Now our converse. So it says write the converse of the last statement. If you work hard, then you'll get an A in the class. Well, we know that the converse, if you get an A in class, then you work hard. Work hard. So that's our converse. So remember, even with the converse, the promise is still to get an A in class. So if we make a truth table for this, so we have true, true, false, false, true, false, true, false. Well, now it's if Q, then P. So if Q, then P. So if Q, then P. So we get true, false, true, true. I wrote that backwards. Sorry. True to true is true. False to true is true. True to false is false. So the third one down is false. And then false to false is still true. Because this is where you did it. So you did it, but you did not get P. Now the inverse of a conditional. So the inverse of a conditional is formed by negating both the hypothesis and the conditional, or the conclusion. So we negate both the hypothesis and the conclusion. So if we have this, if you work hard, then you'll get an A in class. Well, if we negate it, if you don't work hard, then you won't get an A in class. Well, we can look at this also using our truth table. Well, we know it's true, true, false, false, true, false, true, false. Not P, so we negate P, so it becomes false, false, true, true. We negate Q, so that becomes false, true, false, true. And then it says, if not P, then not Q. Well, so we're going from not P to not Q. False, false is true. False, true is still true. True, false is false. And then true, true is true. Now we have the contrapositive. So the contrapositive of a conditional. We form this by interchanging interchanging the hypothesis and conclusion. So we're switching the hypothesis and conclusion. Of the conditional. And then negating each part. So we switch the hypothesis and conclusion, and then we negate each part. So we switch them and negate them. So if we have, if you work hard, then you will get an A in class, we switch them. If you get an A in class, then you work hard, and then negate them. So if you did not get an A in class, then you did not work hard. So if we look at this truth table, all right, P is true, true, false, false. Q is true, false, true, false. Not Q, all right, not Q. So we're going to do not Q, and then we're going to do not P. So not Q is false, true, not P. All right, make sure you didn't switch them up. It's false, false, true, true. So now we're going from not Q to not P. So we negated them and we're switching them. So we switched it. So we did Q first and then P. And now we're going to see our if-then statement. So false, false is true. True, false is false. False, true is true. And then true, true is true. So notice that the final columns of the truth tables for the original conditional. So if you go back and look at the conditional. So here's our final table for the conditional. True, false, true, true. And our contrapositive, true, false, true, true, are the same. So that means these are functionally equivalent. Alright. If a conditional is true, then its contrapositive must also be true. If the conditional is false, then the contrapositive is also false. So which other scenarios are true, are functionally equivalent? Well, we have the conditional and the contrapositive, and then the converse. Let me show you that. The converse, which is true, true, false, true. So that's the converse, and the inverse is true, true, false, true. So the converse and inverse. So the converse and the inverse are functionally equivalent, and so are the contrapositive and conditional. They're truth functionally equivalent. So if we look at this one, we have the conditional. All right, if P then Q, then we have the converse. Well, if Q then P, so if Q then P, we have the inverse. If not P, then not Q. We negate them. So not P, then not Q. And then we have the contrapositive. It's where we switch them. So Q, then P, but we negate both of them. So not Q, then not P. So if not Q, then not P. Not Q, then not P. And which are truth functional equivalent? We said the conditional and the contrapositive, the converse and the inverse, and that means they have the last column in the truth table is the same, which also means that they have the same truth value. So if the conditional is true, the contrapositive is true, and converse is false, the inverse is also false. So now there's a few examples for you guys to work on. Complete them, work with your groups, and stay on task.